In this video, we're going to continue topic 5.4, solving systems of equations word problems. We're going to actually get into ones that are systems in these examples. So looking at example 3, Damien owns a trucking company. For every truck that goes out, Damien must pay the driver $17 per hour and also has an expense of $2 per mile driven for gas and maintenance. On one particular day, the driver drove an average of 40 miles per hour, and Damien's total expenses for the driver, gas, and maintenance were $582. Write a systems of equations that could be used to determine the number of hours the driver worked and the number of miles the truck drove. Define the variables that you use to write the system. So a lot of times when we're doing systems of equations, we will use the variables in the words to represent the words. So we would probably let H equal the hours, and we would probably let M equal the miles. And all we're doing on this one is actually just writing the system of equations. So let's go ahead and read that one more time. So it says that they would have to pay $17 per hour. So we're talking about a money equation here. I'm looking for things that have to do with money. So 17 hours plus it's $2 per mile. So I've multiplied 2 times miles, and then I'm looking in there for another amount of money. So that would equal 582. Now, because I have 2 variables, I need to have 2 equations to be able to solve for that. So I've got to look for something else in the problem. I'm noticing a driver drove an average of 40 miles per hour on one particular day. So I know that the miles equals 40 per hour, and that would give me a system. And in this case, we're not solving quite yet, we're just learning the setup. All right, so let's try example 4. A paper company needs to ship paper to a large printing business. Paper will be shipped in small and large boxes. That sounds like some variables, doesn't it? So let's write those out. So let S equal the small boxes, and let L equal the large boxes. I always use a cursive L because then it doesn't look like a 1. The volume of each small box, so volume of the small box is 10 cubic feet. Volume of the large box is 18 cubic feet. So I'm going to start setting that up. So I would say it's 10 times the small plus 18 times the large, and I'm looking for something about volume. There were twice as many small boxes as shipped as large boxes. That looks like something different. Ooh, look, volume. Total volume of all boxes was 190 cubic feet. So this was a volume equation. So I'm going to set it equal to 190. Write a system that can be used to determine the number of boxes, small shipped and large shipped, to find the variables that you use. Okay, so we've already kind of started it. We only need one more equation. Do you see what I underlined though with the squiggle? Twice as many small as large. So that means that the large equals 2 times the small. Actually, I have it backwards. Sorry. That was wrong. Okay. And it's not erasing on me. Okay, there it goes. So it's the twice as many small boxes shipped as large boxes. So that means my small equals twice my large.